All right, so today we're going to go over the last two sections in chapter 4 we're going to do. We're going to do over 4.3 and 4.6. You do not have to do 4.4 and 4.5. Those are not on homework either, so you don't have to worry about those. So we're going to look at percentiles, box and whisker plots, outliers, and then some proportions at the end. All right, so last class we looked at mean, mode, median, and range. So the median is really like the 50th percentile. It's the number in the middle. So percentiles just gives us the ability to find any number that's in that list. So if you've ever taken the SATs and you looked at your scores, it tells you what percentile you were in based on math, English, and your overall score. That'd be the percentage of students you did better than. So if you were in the 80th percentile, you did better than 80% of the students that took the test. That's what percentile means. Another place you might have seen this, if you're in the nursing program, or if you ever had kids, or if you remember when you were a kid and going to the doctor, you probably saw growth charts. So I just looked at the weight one, but there's also the height one as well on there. So this is the chart that shows from birth to 2 years, 24 months. And I highlighted the 50% percentile, that's the median. Then you see the other breakdowns over here. If you look up here, you have 95 and 98%. If you're in this category, you're overweight.
Or just a big kid.
Well, yeah, but
My son was, they had to make a couple of them. Because he was a big kid.
so the key with this one is you typically don't want to be like, and this is where like this chart really comes into play because my girlfriend's a nurse, so she like actually hears this all the time. Like people go in like, okay, your child's in the 60th percentile. What? And they'd be mad because we are so like programmed to look at percentages as the closer to 100, the better you are. But in this case, you don't necessarily want to be like close to 100. Like that's not where you really want to be.
Like my son was 10, 14, and exactly 24 inches long.
Well, yeah, but if they're like long, like yeah, so it's so as I was saying, it's like you can be up there. There's a lot of people that are up there. It's like it's just a matter of it's not necessarily the ideal situation to be in. So like you don't want to feed your kid, like just keep feeding your kid to get them up there. Like, and she's had people that have done this.
Yeah, but he was over 20 kids. He was just like
Yeah, he was tall. He was big. Yeah.
His head was big.
So, and then the other end also is true. You don't necessarily want to be down the 2 or the 5%. That's underweight. That's another problem area. So we look at these percentiles, and that's the thing. It's like depending on what you're talking about, the percentiles can mean different things on how you interpret those results. So this is just one I like to show just because it comes up quite often. So the first thing we're going to look at, they had a nice little paragraph about this, but I think the actual flowchart is nicer. So we're going to use this flowchart. So the first thing we want to look for is how to find the percentile. So we want to figure out what value is in that percentile. So if you look at this formula, it's actually really simple. It's not overly complicated. The L just means location. The N is the number of values that you have in the problem, and P is whatever percentile you're looking at. You don't need to necessarily worry about dividing 100. It just is moving the decimal 2 places. So if it was 52%, you're looking at 0.52. That's all it is. So you don't have to necessarily take whatever percent and divide by 100. Just move the decimal 2 places, and it does the same thing. So that's a nice little formula. Now, when you multiply anything, you can always get an integer or not an integer. What is an integer? A whole number. So the only difference between it and a whole number is an integer can actually be negative. In this situation, it won't be negative at all. So that's not an issue. So you have two possible outcomes when you divide the number or multiply it by its decimal. You can have it be an integer or not. If it is an integer, you are going to take that value and the next one up. Add them and divide by 2. If you remember right, we did that for median. So if you take it and divided it, say we had 10 numbers, which the middle number would be 5, the fifth number. However, in 10 numbers, the fifth number is not exactly in the middle. There's a fifth in it, so we take the fifth number and the sixth number and then divide them by 2. So whenever we're looking for a location, if it comes out to be a whole number or an integer, we take that number and the next number up and add them up and divide by 2. If it is not an integer, which means it has any type of decimal, you're going to round it always up and then take that number. So
It's like 5.3.
doesn't matter. Whatever, even if it's 5.001, you're picking the sixth number. Okay, so whatever the number, if it's not an integer, you are always rounding up. Okay, so we saw this again in median. So when we were looking at, if we had 9 numbers and we were looking for the middle number, so 50% of 9 is 4.5. We chose the fifth number. So we always went up in that case. Okay. Don't worry, we're going to do one of each of those in a second. So. All right. Okay. Oh, I did miss the very first step. The numbers have to be in order. So put these numbers in order and find me the 50th percentile. So we would take these 7, multiply it by 0.5 for the 50%, or 0.50. We'll keep the 2 numbers there, which gives me 3.5, and I round up. So I'm going up to 4.
I don't understand that.
Well,
Yeah, why 7?
because there's 7 numbers. I have 7 numbers here. 2, 3, 4, 5, 6, 7. So I'm taking the 7 numbers, multiplying it by 0.50, 50%. Change percents, always just move the decimal 2 places. Multiply that, you get 3.5. And I said if it's not an integer, we always round up. So that's how I got the 4. So I'm going to pick the 4th number. So 1, 2, 3, 4. So that is my 50th percentile.
Wouldn't that be the median? I'm like, wouldn't that?
Yes, that is the median. 50% is in the middle, right?
Right.
So that would be the median.
Because that's the number, like, I didn't even do all that, and I just, like, I picked right.
Correct, because that's the median. 50% is the median. But let's say I wanted the 80th percentile. Now we're going to do the exact same steps. We're going to follow this process. 7 times 0.80 is 5.6. So this would be my 6th number. We count over 1, 2, 3, 4, 5, 6. So that would be 7th. So when we're looking for median, it was just the middle number. That was fine. Percentiles expands that out so I can find any number. Okay. And both those numbers came out to be above the 0.5, but it doesn't matter. You're always going to round up. Okay. All right. I gave them to you in order this time. Find me the 10th percentile and the 88th percentile. And there's 40 numbers here. So we'd have 40 times 0.10 is the fourth number. Is that an integer? Okay. So that means I'm going to look at the fourth and the fifth number. So I'm going to look at those two numbers. Okay, because an integer, you're looking at that number and the next number. So I'm going to take those two numbers, add them up, and divide by 2. So 27 plus 29 divided by 2 is 28. So the 10th percentile is 28. Okay. And if you look at it, if I go here and I say, okay, that's 28, I have 1, 2, 3, 4 numbers below it, which would be, that's why that's the fourth. That is the 10th percentile. 88th percentile, 40 times 0.88, which is what? 35.2. So that means that is not an integer. So I'm going to take the 36th number.
But you always round up.
Always round up. So that would be 73.
Now,
2600, 36 and 71.
40, 39, 38, 37, 36.
so
Yeah.
you wouldn't do with anything with 73, which the answer would be.
That the answer is 73. Yes, the answer is 73.
So why did you take 27 and 29, add it, and divide by 2?
Because it came out to be an integer. And the rules, this 4. That 4 was an integer. And the rule says if it's an integer, I take that number and the next number, add them and divide by 2. So in this case, that 4, so I take the fourth number and the fifth number, add them up and divide by 2. Since 88 was not an integer, I round up and that's the number I take. All right. The next thing you might want to do is if you think about your, like the SATs, they tell you the percentile, but you got your score and then they're going to take your score and then determine the percentile from your score. So you might have the number and you want to find the percentile that attaches to that number. So when you're doing this, you're taking the number of data values less than or equal to that value divided by the total number of values. Okay, so you need to figure out where your number is in the list. And then you divide that by the number of values total in the list. The times 100 is literally just, again, to move the decimal point. So if I want to find the percentile for 32. So what percentile is 32? So I would count how many numbers are less than or equal to that one. 1, 2, 3, 4, 5, 6, 7. So there's 7 numbers less than or equal to it, and I divide that by 40 because I have 40 total numbers. So it's 7 divided by 40. What was it? So that'd be 17.5%. So that's the percentile it's in. Actually, yeah. You probably want to round that up to 18 because typically percentiles are whole numbers, but okay. So you count that number back, and that's all you're just dividing it by the number that's there. Yes. Hawks will want 18. Because it's always the percentile is always a whole number in that respect. So
What was the question for this one?
what's the percentile that 7 is, or 32 is? Actually, give you the rule. It does not. Interesting.
Did you say it was?
Huh? No, it will not always be in order. The one we did up here, I just gave you this one in order, so you didn't have to put it. Like that one wasn't in order. So the numbers they give you do not necessarily have to be in order. This one actually had 2 tables. One was not in order, one was in order. And I'm like, I'm not going to make you sit there and put 40 numbers in order first. So I figured I'd give you that one. All right. So percentiles, you can find any percentile. You can find any number from 0 to 100 and percentiles. There are ones that we specifically want to look at, though. We really want to look at what's known as the quartiles. These are the important ones. The quartiles are splitting numbers into quarters. So you have the 25th percent quartile, 25th, 50th, and 75th. Now 50 is your median. So your 25th is Q1. Your 50th is Q2, which is also typically known as, that's your median. And your 75th is Q3. Okay.
So my friend asked me last night, he says, how come there's no Q4? Because there's 4, like.
There's also no Q0.
But he was referring it to like football. He was like, there's 4 quarters in a like football game.
Right. So these aren't the actual, so these are the splits between the quarters. So these would be the breaks. And in a football game, there's 3 breaks.
Got it. I'll find that.
Yeah, that's right. That's, and actually, and when we're looking at these, is you actually are going to have, it's a 5-number summary. You also have a minimum and a maximum, which gives you the other endpoints. So yeah, so these are the actual splits between the quarters.
Got it, okay.
So if you want to take something and break it up into 4 pieces, you actually make 3 cuts, not 4 cuts. So, all right. The other thing that we talked about on last class, we talked about range. Range told us the minimum to the maximum. Okay. Interquartile range is looking at the difference between Q3 and Q1. Okay. So it's looking for that middle section. So interquartile range, we would subtract Q3 minus Q1. And we're going to look at that in a second, actually, when we're doing the next set of numbers.
Which would be your median, correct?
No, your median is the middle number. So this one, when you get your quartiles, you're actually going to subtract the actual numbers. It's not necessarily going to be the number in the middle. You're telling me how wide that range is between those 2 numbers. So, all right. So for these set of numbers, I want you to find me my 25th, Q1, 50th, median, and 75th, Q3. So find me those three numbers for this problem. They're set up in a way that'll help you. They're very in order, first of all, but they're actually organized in a way that's going to help you too. First thing you have to do is calculate which number you're looking for. Do what we did in the last one. Do this, not this. This. 40 times whatever the number percentage is. Start there. So this one is 40 times 0.25.
Oh, that number's going around.
You're not looking for the number 10. You're looking for the 10th number. So Q1 is going to be 10. So it's 41 and 43. Because you look at the 10th and the 11th number. So Q1 is 42. Median, you're looking for your 20th number. So that's, you're looking for 20th and 21st. So 54 and 54. Add up, divide by 2, still get 54. 40 times 0.5 is 20. 20th number, 21st number. If it's an integer, yes, you'll always do the next number up. So 40 times that is 30. So I'm looking for my 30th number and my 31st number. So 64 plus 66 divided by 2 is 65. What's 40 times 0.75 on your calculator? Right, now count to the 30th number. Each column's 10 numbers.
So 64.
And we always have, since it's an integer, we have to take the next number too. 30 is an integer. There's no decimal. So the rule stated,
Oh, they have to add them.
I have to look at 30 and 31.
4 and 56.
Right, add them and divide by 2, you get 65.
So like, so 20 is the 54 and
54. The 20th number is 54, the 21st number is 54. Right. The 10th number was 41, and the 11th number is 43. That's how I got 42. Yeah, 41 plus 43, 84. 84 divided by 2 is 42. You'll never see me write out an interquartile range. I will always write it as IQR. Way too long to write. So your interquartile range is the difference between the Q3 and Q1. So Q3 minus Q1 is 65 minus 42, which is 23. So my interquartile range is 23. Okay. The other two numbers that are important when we're looking for them is my minimum number and my maximum number. So what's my minimum number here? And my max? And then what's my total range? 82 minus 18, which is 64. And that's my total range. Okay. So in essence, what this is doing is it's breaking it up into groups of, in this case, 40 numbers. You're breaking it into groups of 10. Each quarter has 10 numbers in it. So any questions? Everybody understand where these numbers all came from? Now I'm going to show you how to, we can talk about how to use them. All right. Our 5-number summary. So our 5-number summary is the minimum, the first quartile, the second quartile or the median, the third quartile, and the maximum. That's what's known as a 5-number summary. The graph of that, they call it a box plot. It's a box and whisker plot. Yeah, that's what I've always known it as, because you have your box in the middle and your whiskers going out to the sides. Box and whisker plot. So you'll notice those 5 numbers that we just found are here. My min, my max. Q1, Q3, and my median. So what that does is it's breaking that set of numbers up into 4 quarters. That's my first quarter, my second quarter, my third quarter, my fourth quarter. Each of those pieces have the exact same number of values. They are not the same width, they're the same number of values. So between 18 and 42, I have 10 numbers. There was 10 values. Between 42 and 54, I have 10 values. Between 54 and 65, I have 10 values. And then 65 and 82, I have 10 values. And if we look at the chart, between 18 and 42, there's 10 values. Between 42 and 54, there's 10 values. 54 to 64, there's 10 values, or 65, sorry. And then 6 to 82, there's 10 values. But if you look between 54 and or 43 and 54, that's only 11, like actual like counting values. But between 18 and 42, 23. Okay, so it's not equally spaced. It is the number of values in that term, in the data set that you have. Okay. All right. That's a box and whisker plot. Any questions on how we got a box and whisker plot? All right. It is just a graphical representation of the 5-number summary. So instead of just give me the 5 numbers, they can put it as a picture. And just like we were talking before, a picture can give you a lot of information about what's going on without having to look at every single possible number. All right. We have talked about an outliers a little bit. We looked at certain situations where the number was just way far out. We're like, okay, that's an outlier. However, there is an actual definition of an outlier. An outlier is 1.5 times the interquartile range above 75th percentile, or 1.5 times below the 25th percentile. Okay, so we have to do a little calculation to this. Okay, I have one more to set, right? Yes. Nope, I did not. That's okay. All right, so in the last set of numbers, my min was 18. Q1 median was 54. It was 84, right? 82. Okay. My interquartile range was what? 65 minus 42, which was 23. All right, so let's look at, now we have to do my calculation. So for my outliers, I'm going to do 1.5 times 23, which is what? Okay, so 34.5. So we're going to change this, always round up, so 35. So to find my low end, I take Q1 minus 35, which gives me 7. In my upper end, I take Q3 and I add 35, which gives me 100. So any number less than 7 or greater than 100 are my outliers. In this data set, do I have any points that would fit that? No, because my minimum was 18 and my maximum was 82. So I had no outliers in this data set.
Where are you getting the 35? Oh,
1.5 times 23.
where are you getting the 1.5?
The rule. It's always 1.5.
So,
1.5 times the interquartile range.
okay,
Add that to the Q3, subtract it from the Q1. Anything outside of those numbers is my outliers.
so you would take the 65.
Yep.
Plus the 35.
Correct. Get 100.
Okay.
And 100 or greater, outlier. And then for the Q1, I subtracted the 35. So 42 minus 35 is 7. At 7 and less, outlier. That's it. All right. Your turn. I'll give you 15 minutes. That's about as much time I'm going to be able to give you before. Otherwise, we're not finishing before the end of class. Actually, I'll make life a little easier.
Use them in corner.
Yes. See if I can actually.
I don't feel like digging out my. So,
Unfortunately, I can't make it any bigger, but that's them in order. So that'll save you that time. So find me Q1, Q2, Q3, interquartile range, and then make me a box and whisker plot and tell me if there's any outliers. One step at a time. There's 30. Sorry. Yes. There's 30 numbers. Yes, there's 30 numbers.
Hey.
Sorry. They're the same numbers. I didn't change them. I just moved them across the screen.
No.
So,
Box and whisker plot. So Q1, Q2, Q3, the interquartile range, box and whisker plot, and any outliers. Sketch it. Doesn't have to be perfect, but sketch one. It's good to actually like practice that, like actually sketching one out. That should be your 5-number summary. If you didn't get that and you don't know why you didn't get that, or if you're still working, keep working. But if you didn't get that, don't know how you got it, tell me, and I'll come see it, figure out why you didn't get it. Yes.
For Q3, I got 85. I might have just counted wrong when I was counting down from here.
Probably. So let's see. 75% of 30 is 20, so the 23rd number.
Yeah.
Yeah, it is 84. Yeah. So 22.5, you're taking the 23rd number. I didn't calculate it. I used Rugio to do it. So I know those are the right answers. Yeah, it's really easy to miscount sometimes.
Is the 23rd number 85?
No, 23rd number is 84
Okay, I did three.
because that's 30. Because I normally when I'm that far, I count backwards. So 30, 29, 28, 27, 26, 25, 24, 23.
And when you're finding the high outlier, are you adding Q3 to the whatever the number comes.
Yes.
Okay.
So what are we looking for now? We're looking for the min max range, the Qs.
Yep.
What was the other question?
Interquartile range.
What is,
The IQR. Is Q3 minus Q1, which in this case would be 44.
yeah, I got it.
And now my outliers. 44 times 1.5, which is 66. Yes? Yeah. So I take,
What was the other question?
well, I gotta find my outliers still,
Oh, your outlier.
or if there is any outliers.
You're gonna have negative.
Yeah. So Q1 minus 66 is negative 26. And Q3 plus 66 is 140? No, 150.
I'm a little confused about outlier. You're always multiplying.
Always multiply by IQR by 1.5. And then,
IQ1.
yes. It's always that's where the interquartile range comes into play. It's like that's what you're trying to decide. Is it so far out of range of that middle piece that I'm not using it?
And then you add it to.
Right. You're adding it to your Q3 to go one direction, and you subtract it from the Q3 to go the other direction.
Multiply the.
Oh, yeah, no. So it's less than negative 26 and 150 or greater. So in this case, there is no outliers
Why isn't it 84 times?
because 84 is not my IQR. I have to find my IQR first.
So in the definition for outliers, it says 1.5 times the IQR and then below or above the 75th or 25th percentile. So could you just do the multiplication for that and then look at the 75th and 25th?
Oh, yeah. So in this case, you don't necessarily have to subtract it.
Yeah.
So, well, you just have to make sure that it's going to be that far. Like in this case, you can easily tell there's going to be no outliers. That's not always going to be the case. So there is certain situations that there will be outliers. This problem just didn't have any. Because we were looking at actual like scoring, so it has to be between 0 and 100 anyway. So, but the next problem, I actually will have outliers in it.
So is there a case where there would be an outlier, but if you were to do the 44 times 1.5, and that number wouldn't be above the 75th percentile until you did the addition, and then it would say that is the outlier? That makes sense.
That didn't make sense. That's okay. Okay. So things over the 75th percentile do not automatically mean it's an outlier.
Okay.
So because you have numbers between the 75th percentile and the 100th percentile, like those are that there's an actual range there of values. Okay. So an outlier is one that's so far outside of that range that it's would skew the data.
Yeah.
So like the situation we had, like the 490 would skew the information. So in that situation, we wouldn't want to look necessarily at that value. We're going to look at other stuff that's in there.
So you should just be safe, always do the addition.
Yeah, you always, but like I said, like in this situation, when you add, if I'm adding, the max is 100. If I'm adding 66 to 84, I know it's over 100. So you don't necessarily need that number. You just need to know, okay, there's no outliers here. And the other direction, somebody automatically said, oh, it's going to be negative. I don't have any negative numbers, so I know there's going to be any outliers there. So you don't necessarily have to add it. You have to be able to understand what the addition or subtraction is going to do to give it to you. If it runs into that range where it might be, then do the adding and subtracting actually to get the number to figure out where it's going to be. So yes.
If there was a value of 150 or above, it would just be an outlier.
Then it would be an outlier, yes. So yeah, if I added 175 to this list, it would have been an outlier. Yes. Yes, it is exactly the center 50%. It is all. Yes. That's a way to think about it. Yes. All right. So if we want to do a quick little box and whisker plot sketch, all you need is a nice little number line. So 20, 40.
So there's no outliner for this?
There is no outlier for this.
I don't get it.
Why?
Because one's like -26 and the other one's positive 150.
Right, but I don't have any numbers I don't have any negative numbers on this list.
Okay, but,
And I don't have 150 on this list.
yeah, but that's like way out of like the range.
Right. That's why I don't have any outliers.
But I thought those were outliers.
No, that's where the outliers start. -26 and 150 are where my outliers start. I then look at my data, my 30 points that I have here. Do I have any numbers that are less than -26? Do I have any numbers that are greater than 150? Then I have no outliers. Those are telling you where the outliers begin.
If there was a number less than -26, then it would be an outlier.
Hold on. Let me find a list that actually has one. Actually, you know what? No, I'm going to show you in the next problem because the next problem I already have set up with the outlier. All right. So my minimum was 26. So I have a line there for my minimum. My maximum was 84. So I have a line there for my maximum. My Q1 was 40. My my maximum was 100. My Q3 was 84. And my median was there. So here is my box and whisker plot. Okay. Quick little sketch of a box and whisker plot. All right. Now, this one was 30 numbers. It's not horribly hard to sit there and do it out by hand. But when you go into your Raguru site, the first thing that's going to come up is a blank screen with a whole bunch of like things you can type numbers into. So I typed those numbers in. That's how I got in order. I actually did this in my last class. So I typed all the numbers in. So all 30 numbers are there. And you can easily click on this. It'll actually resort it for you. You save. Always have to save. And then if you click that little summation button right there, it's going to give you your values. And that's where I got my min, Q1, median, Q3, and max. Okay, so it will do it for you. You just have to log into it to do it. On the test next week, you either can do it on your own device or you can use the computers in front of you. I would suggest having this open, having some kind of, when you're doing your actual practice test, use this. It's going to make your life easier because even looking for means there, standard deviation, your variance, all those numbers are there already for you. So it will save you having to do all those calculations out. Okay? You just have to practice actually using it. Now, the other thing it will do is it will do a box and whisker plot for you. So there's the box and whisker plot of what we just did. Okay?
Will you see all this if we do it on our own computer? Will you see all this?
No. You're putting into Hawks. The test is on the computer.
Well, that's what I'm saying. So you'll see all of our work on this for our test.
No, I won't. I won't see this stuff on the test. No. I'll see your answers
Well, that's.
because you're putting the answers right into Hawks. So Hawks is going to tell you if you got it right or wrong. You're not doing your paper test out on paper.
Okay.
Okay. Anything if you want after you're done with the test, if you want to hand in your work, like this, obviously you're not going to do the calculations. You did it on Rubio. That's fine. But if you have work that you'd like me to hand in so I can look at it to see what you've done,
Oh,
that's fine. I will take that and I can take that into account. Yes. So obviously this, you will not be able to hand in because it was done on the computer. Okay. All right. So there would be my box and whisker plot. The next problem we're going to look at. So this one, they're giving you the data set. This data set actually has 1,232 data points in it. You are not doing this out by hand. Okay. This one you have to use Rugo for. Okay. In your data set over here, you can look. All these are options right here of different data sets. So this one's called Moneyball. It's all about baseball. And we're looking at the on-base percentage. We're looking at this column right over here. So save. We look at that. If we go down to OPS or on-base percentage, we now have our min, max. We have all that information right there. Min, Q1, median, Q3, and max. Okay.
Does it say Moneyball on that data set?
Yes. Yep. It's called Moneyball. Hold on. I'm getting something so I can actually have you guys do something real quick. Because I already had it done in my other class and I want you to actually be able to do this one up by yourself. So. All right. So here's that information. I want you to find me my IQR, my interquartile range, and I want you to find me where my outliers start. Okay? So find me my IQR and find me where my outliers are. Okay? IQR, outliers. Those are the
Can you
two.
do this on paper?
Yes, you can do this on paper. That's fine. This is something you absolutely can do because it's a very simple calculation. So yes, this I would do on paper. Rubio won't give you this. At least if it does, I haven't found it yet. Interquartile range, 0.020.
Zero.
just because the other ones had 3 decimal places, so I kept it the same as the other data. Your outlier, 0.020 times 1.5, 0.030. Nothing. It means nothing. It's just a number that you're going to use elsewhere. So now I'm going to do Q1 minus 0, which gives me, Nope, you have your 3 in the wrong spot. Yeah. And then Q3 plus 0.030. Okay. So we have, it's going to be less than 0.287 or 0.287 and less than, and then 0.367 and greater than. Do I have any outliers in this data? Yes. Because if we look at my minimum and my maximum, they're both outside of that outliers. Okay, so I have outliers in my data. So let's go look at the data and see where those outliers lie. So if we look at this, it was 0.367. So I have those 2 are my outliers. No, because that's going to be my borderline. That's actually going to be my new maximum. So 0.369 and 0.373 are my 2 outliers. I can't remember who was that player.
Oh, this is really.
Yes, these are actual real data. Hold on.
So what were the answers?
There you go.
Oh, I got the answers for you. Okay. Who's the first?
Yes, it's Roberto Alomar. That's who that was. So if we look at it, if we look at the actual data points, those 2 are outliers in respect to all the rest of the data on the high end. If we look at this, we also have outliers on the low end because my minimum was below the 0.287. So if we go back here, I can switch this around to look the other direction. And I have all those are outliers. 2, 3, 4, 5, 6.
So they're never equal to.
No. So I have 6 or 7 actually. 7 values that are outliers.
Oh, because they're less than the.
They're less than the 0.28. Yes, they're less than the 0.287. Okay, so this is where we have outliers. One of the questions came up in the last class was, can we have more than one outlier? Yes, you absolutely can. You're typically not going to if you have just a very small set of data, but when you have a lot of data, you absolutely can have multiple outliers on both ends of it. Okay, so now if we look at the box and whisker plot for this one, you'll notice. So this line right here is at 0.287. This line is at 0.367. That is not my minimum and my maximum anymore. That is the center edge of where my outliers would start. Okay. And then these are my outlier points. Don't worry about the X. It's just because there's multiple points at that point. So those are all my outliers. Okay. So
What are your, what's your box?
the boxes that enter 50%, that's still your interquartile range. This is still Q1, and that's still Q3, and that's still Q2 in the median. That doesn't change. The only thing that changes on the box and whisker plot, if you have outliers, is you don't use your minimum max. You're going to use where your outliers would begin. If, let's say we didn't have these two outliers over here, that would have been my max. Okay? So that's how we mark out outliers. All right.
Good question.
Yes.
So if you don't have outliers, the min and max don't change.
Correct.
Do they do change?
Yeah, you're not going to use your minimum max. You're going to use where the outliers would begin, because that's the farthest level of where you're going to look, and then we have things that don't really represent the data. All right. Here's a bunch of box and whisker plots. This is how you can start using it to be able to figure things out, okay, and actually use the information. So this is the only difference between this one and the one we're looking at. These are vertical instead of horizontal, but it's the same concept. Can somebody that has less than a high school diploma make more money than somebody that has an advanced degree?
Yes.
Yes. Where's the maximum for the high school diploma? Just about 1,000, right? Where's the minimum for an advanced degree? Like 750. So yes. A person with less than a high school diploma that didn't earn a high school diploma can earn more than somebody that has a master's or a PhD. Okay. Now, in the grand scheme of things, no, there's a lot more above on the advanced degree, but you'll notice that as these boxes get bigger, they get spread more further out. There's a lot more variation in them. So, and like this one, more than 50% of the stuff is above the bottom part here. So it's like the bachelor's degree actually doesn't have as much of a high end, but it's comparable to the advanced degrees in that respect. So you can start to see how we can, without having a bunch of numbers and data, we can start looking at that box and whisker plot to get some information about what's going on. The other place you'll see box and whisker plots used quite often is in stocks. They'll look at the range of values that they're going to and how much it actually changed during that day, and you can see that spread out. You will see it there as well. All right, one last thing we have to do. Very simple. Proportions. You've done these. This is not very complicated. Just the definition makes it more complicated than it is. All a proportion is the fraction of a group that possesses the characteristic. So all it is literally how you find percentages. You're going to divide the two numbers and figure out that's what percent of the people are. So I have 48 students in my class. 4 of them are left-handed. So what proportion of the class is left-handed? It's 4 out of 48. So you're going to divide 4 by 48 and get that number, which I believe comes out to be 0.833. So about 8.3%. That's it. That's all a proportion is. That's section 4.6. That's all section 4.6 is. Okay. All right. Any other questions?
So we don't need to know anything about rank for these 4.
No. And it's not going to be on your quizzes or tests or anything else. You will, not now. The reason why I moved that is because we're not going to end up using it through chapters 6